we need to have a talk. No, not about that. We need to talk about memory allocation on APUs. People get worked up on the quantity of memory reserved to the GPU without stopping to think about what the overall system consequences of this decision are. Let's do that in this video. Put this issue to bed once and for all. Welcome back. APUs are a miracle to low-end gamers in this overpriced GPU era of cryptocurrency mining. They provide good CPU performance, decent GPU performance, and a nice low-power, easy-on-the-wallet package. Now, of course, there are trade-offs and decisions that need to be made. Today, we need to talk about memory. Traditional GPUs have their own memory on board, VRAM, to facilitate frame buffer, textures, and whatever information the GPU is needing to process. This memory is most often GDDR5 or in some cases HBM and comes in quantities of 4, 8, or even 16 gig. Both of these memory types are extremely fast at feeding information to the GPU, but it is only one place that the GPU gets information from. Whenever an application or game needs to store graphics data, it uses this VRAM as a primary location. But if ever there is more storage needed than the graphics card has to offer, it will offload some into system memory. System memory is much slower than VRAM. We're talking tortoise and hare speeds here. The RX Vega line using HBM2 memory has a bandwidth of around 484 gigabytes a second. On the GTX 1080 using GDDR5X memory, you get a memory bandwidth of around 320 gigabytes a second. Both of these technologies are blistering fast, especially when compared to DDR4's memory bandwidth of around 35 gigabytes a second. So what does it have to do with memory allocation in my shiny new Ryzen APU? A lot, actually. Being that there's no traditional VRAM on board, everything is being allocated to system memory. There is technically no VRAM, regardless to what you've specified in your BIOS. It's just a chunk of system memory that you are telling your operating system it cannot use. So let's take a lower-end system. Most cases, APU systems will fall into this category due to just price constraints. The system has a total of 8 gigabytes of DDR4 clocked at 3000 MHz. With the quote-unquote VRAM set to 2 gigabytes in the BIOS, you're limiting all applications to work with only 6 gig of memory. This is everything from the operating system to the memory-hungry Google Chrome browser and any other applications you may want to run. If you've used a system with less than 8 gigabytes of memory lately for browsing the web with a few tabs open, you can start to see where the problem lies. Now let's look at a game in the same situation. Our GPU is reporting that it has 2 gigabytes of memory, which it technically does, but we'll still use more than that if the textures or some other processing in the engine needs more memory. So more often than not, you're going to be using more than that 2 gigabytes of memory to operate and take away from the system memory anyway. Since we do not actually have high-speed VRAM, we might as well let the operating system and the drivers handle memory usage to make our everyday applications run better, having access to something like 7.5 gigabytes of memory. This will give everyday applications such as the web browser the memory headroom they need in order to facilitate multi-tab and high-demand JavaScript web applications. Being that you're most likely going to exceed the 2 gigabytes of GPU memory anyway, and the system memory is the exact same speed as your quote-unquote VRAM, what are you losing? I say nothing. So what are your thoughts on memory allocation on Ryzen APUs? Leave a comment below and let's start a discussion. If you like this video, leave a thumbs up. If you want to see more, click subscribe. Thanks for watching.